Okay, now with trig equations, it's different from other equations. What we need to remember, I'm just going to draw one sine graph here, which I do want you guys also just to copy down. Just going to do a very basic one. Just going to zoom in a bit. So we're just going to go up to 1 and down to -1. I'm just going to make this line a bit longer. Let's do 90, 180, 270, and then 360. And guys, we haven't done trig graphs in a long time, but obviously they are going to be in your end of year exams. Right, so yeah, I'm not sure what the schedule looks like towards the end of the year for how much time we're going to have for revision. But we are going to have to try and fit some revision in at some point. Who was it? All right, so sorry, that looks a bit wonky, but those are, do we remember the period of the sine graph is 360, right? To get the step, we divide that by 4. So that's why I did my 90, 180, 270, 360 thing. So I'm just going to write on the side there. The period is 360 degrees. So for the step, we divide by 4. Which is 90 degrees. And this is just the normal sine graph, the most basic one. Okay, so do we remember where the normal sine graph starts? What that first point is? What's the shape again? Does it start at the middle or does it start at the top? In the middle, right? So it's going to start at 0, 0. Then your step is 90. That means that your next point that you're going to plot is going to be at 90 degrees. Or after 90 degrees, and that is going to be at 1. Then we're going to go back down to 0 at 180, down to -1 at 270, and back to 0 at 360. Remember I said earlier in the year that it's important that you know the basic shape so that you are able to recognize it, especially when you are asked to find the equation of a graph. Okay, I'm just quickly going to freeze there while I draw my curve in. Now guys, the fact that this graph ends at 360 degrees here, that's not necessarily the case, right? What happens with the sine graph? It's going to keep repeating its shape every 360 degrees, right? That's why we say that the period is 360. So I'm going to write here, okay, repeats every 360 degrees. Okay, now I'm going to come back to why we went over that in a little while, okay? Because the fact that the shape repeats every 360 degrees, we're going to have to work that into our answer somehow, okay? So we can just press pause on that. I'm just going to show you a very basic sine or trig equation quickly. So if you can just write examples. And we are going to solve for x. First one that we're going to do is sine x equal to 1. Now guys, in grade 10, you actually did solve trig equations, right? They would have expected you to do this. But in grade 10, they would have said, and you didn't understand the importance of it yet, but in grade 10, they would have said where x is between 0 and 90 degrees. Okay, that was always the instruction there. Now it's just saying solve for x. Can anyone remember, how can I get the x on its own if I have sine x equal to a number? We don't necessarily divide by sine, because actually sine and x, these two are almost like they can't be separated, right? Sine is not like a variable on its own that you can just divide. Do you guys remember shift sine? Right, so that is kind of like dividing, not exactly, but you would say that x is equal to, and what you're going to write down is sine to the -1, and then you'll put 1. But now, guys, it's not saying between 0 and 90. It's just saying solve for x. Now, I'm going to write this down now, what this is. Let's look at our graph, guys. Where is the graph of sine x equal to 1? That's what they're asking us here, hey? At what x value is sine of x equal to 1? 90. But guys, isn't the shape going to go again after 360 degrees? And again, and again, and again. So we can't just say that x is going to be 90, because x is also going to be 90 plus 360. X is also going to be 450. And then another 360 degrees after that. And another 360 degrees. And also, what happens here in the negatives, guys? This shape also repeats backwards, right? Every 360 degrees. So we're going to have the same point, the same value of 1, 360 degrees before this one as well. So we have to say plus 360 degrees times n. And then n is an element of z. Can anyone remember what that symbol means, z? What types of numbers are those? Okay. Integers, right? What are integers again, guys? Negative or positive whole numbers. So z, that represents integers. And integers are positive, or negative whole numbers. So that is the extra bit that we have to add in when we're doing a trig equation, which we won't do with a normal equation. Because when we're thinking of trig graphs, they repeat the same shape, the same values every 360 degrees. Now, if you type in shift sine, right, we can already see what it is from the graph, but just in case it's something different, you'll say shift, the shift button, then you'll press the sine button, and then it opens that bracket for you, and you just press 1 equals, and it gives you 90. Okay, so shift sine of 1 is 90. So actually here we have that x is 90 degrees plus 360 degrees times n. That n is going to stay there, guys. This is actually giving us a formula for values of x. So it's not actually a specific x value that it's giving us. This is the formula that can give us any value of x, where sine of that value will be equal to 1. So I can do, for example, let's say sine of 90 plus 360, right? If I'm saying 90 plus 360, what is my n value? It is just 360. 360 times what is 360? 1, hey? So let's see what that is. 1. Let's do 360 times 2. Because what did I say? N can be any positive or negative whole number. 2 is a positive whole number, right? What's that? 1 again. If I put in 10, what's the answer? 1. So all of those x values that I'm putting in here, right, are 90 plus 360 times something. We can also do negative values, guys. If I do -1, because remember an integer can be a negative whole number as well. What do I get? 1 again. Okay, I can again change it to -25. 1. Okay, so this is not the value of x. This is actually a formula that can give us any value of x that will satisfy this equation. Right, we call this the general solution. That is the term for this. Right, the general solution, normally for like a general term or general formula, that's what we say if it's like the rule. Okay, so general solution. So this is actually a formula for any x value that makes the equation true. So I'm just going to say that makes equation true. So instead of giving one answer for x, which is what we're used to, we're actually giving them an infinite number of x values, all right? Because I can make in any positive or negative integer, positive or negative whole number, and it will give me a value for x that will work. Guys, you're going to leave your answer like that. That is the final answer. Okay, we can't list specific x values because where am I going to stop? Right? I can say 90, I can say 450, I can say the next one, but where do I stop? Okay, so we have to leave this as our final answer. That is the answer for x. All right. Any questions at this point? I know it's a bit iffy because it is very different from what we've done, right? Now, one where it's not a nice number like this, like 1, okay? Sometimes we can get different types of values. So I'm actually going to show you step by step a method that will work in all cases. All right, if they're giving you 2 cos x equal to, let's do 0,2. And we need to solve for x. So guys, you're not always going to be given a graph, and you're not always going to, I don't want to draw this graph now and see exactly where it's equal to 0,2. All right, that's going to take a long time. What we need to do we remember with any equation, you always make x on its own. You need to get x on its own. With a trig equation, we need to get the ratio, the trig ratio. So sine or cos or tan plus the angle on its own. Okay, so I need to get cos x on its own. Instead of in the past, we wanted to get x on its own first. So I need to get rid of that 2 there in front. So I suppose step 1 would be to isolate the trig ratio. Okay, just write that there. That is the first step. And guys, that's also what you would get your first mark. Just for getting the cos x in this case on its own. So what must I do with that 2? Divide by 2. So I'm going to say 0,2 divided by 2, which is actually 0,1. So cos x is going to be equal to 0,1. That is worth a mark, guys. Knowing that you must isolate the trig ratio. Get it up on its own. Now with the cos graph, it is, well, with any graph actually, it can be a little bit different. I'm quickly actually going to show you guys this graph just on here. Just give me 1 second. Where's this app again? I'm doing y equals cos x. Sorry, almost there. Okay, so there is y equals cos x. They've given it, oh, these values are a bit odd. Let me see. All these degrees. Angle unit degrees, yeah. Okay, so why is it so small? What's going on here on this x-axis? Okay, let's ignore that for now. I'm not sure why it's valued like this. Okay, but let's pretend that that's a 0 and that's a 90. That's what it's meant to be. I think it's in radians, even though, which is a different angle measurement, which we don't talk about. What I just want to show you guys is that if we have a Cos graph, right? And here we can see it very nicely. It's going on forever and ever into the negative x values. And also if we go to the positive x values, it repeats every 360 degrees, right? Which is what we just spoke about. Now, guys, here on the cos graph, what is that equation saying? 0, 1, right? Where is cos x equal to 0, 1? Now, this is 0 and this is 1. So I think 0, 1, let me just check, is over here. I can't actually put a point there. But, okay, that's 0.5. This is better. So I don't know if you guys can see there is a little line there, but it's very faint. That is 0, 1. So do we already see that we have a value there? And then in the same 360 degrees, we have another value where it's also equal to 0, 1. So when we said sine x equals 1, there was just one value in the graph that we drew, right? Where it was equal to 1. For this one, in the first cycle of this graph, there are actually two, right? There's a value there and there's a value there where it's equal to 0, 1. Sometimes that is going to happen, guys, that you actually have two general solutions. So what we need to do in order to get that, okay, first step is done. Second step is we're going to calculate a reference angle, which I think we did in analytical. You guys remember when we did angle of inclination, we did a reference angle. Okay, so we're going to calculate RA. You are allowed to write RA, even in your matric finals, the reference angle, which in this case is going to be shift cos of 0, 1. Okay, that is your reference angle. In the previous one, we said x is equal to, but going forward, let's say reference angle is going to be shift cos of that number that was on the right. Okay, 0, 1. So that's always going to be your second step. Okay, so let's do that actually, and you'll see how I'm going to write it in my solution. I'm actually going to say reference angle is equal to, you can write cos to the -1 of 0, 1 if you want. We wrote it in the step on the side, but you can put it as a part of your solution. Okay, we're going to type that in, shift cos of 0, 1, and we're going to get an answer of 84,26 degrees. Okay, that's going to be our reference angle. 84,26 degrees. Now, guys, this is actually going to be the first value. Remember on that graph, there was one value here and then another one, right? So the first value where cos was equal to 0, 1 is 84,26. But then there was a second one. Okay, now to get the second one is a bit complicated, and we do need to follow a bunch of steps to get there. So step 3 is going to be, you need to look at this line here, where you had your trig ratio isolated, where we had cos x equal to 0, 1. Guys, is 0, 1 positive or negative? Positive. Okay, so we're going to look at the sign of that value. Is it positive or is it negative? Okay, so I'm going to say, look at, shall I say 1? Because this was 1. Hey, take that one. So look at 1. Is the value positive or negative? And this is all a part of step 3. So I'm going to say, then identify quadrants. So we're going to use our Cos diagram again. Okay, so we said that it's positive, right? Now, guys, in which quadrants is cos positive? That's what I mean by identify quadrants. So you look at, it's a cos equation and it's positive. Where is cos positive? Quadrants 1 and 4. Okay, but guys, I normally do like a little cos diagram right next to this. So I don't know if you have space, you can do it anyway, but I normally write it next to the actual value. And then I'm going to look at my quadrants. Remember, it's positive. Cos is positive in quadrants 1 and 4. So then I'll put a little plus in those two quadrants. Some teachers do like a tick in the quadrants. Okay, it's up to you whether you want to do a tick. I'm just going to put a plus because it is positive there. Okay, so now guys, what this means is I need to write a quadrant 1 general solution and a quadrant 4 general solution. Because those are the two quadrants. If I have angles in quadrant 1 and in quadrant 4, my answer for cos is going to be positive. Remember, I'm trying to find an x value. So that if I say cos of that value, it will give me positive 0,1. So whatever my x value is, it has to be an angle either in quadrant 1 or in quadrant 4. Because those two, or angles in those two quadrants, will give me a positive cos value. Okay, so what we're going to do, and this is now step 4. I think let me put it over here because I'm going to do this next now. Step 4 is I'm going to set up quadrant 1 and quadrant 4 general solution. We're going to practice a whole bunch of these. I know for the first one, because in steps everywhere it is a bit democard, but we're going to sort it out. So guys, I normally physically write down quadrant 1. And then for the next one, I'll write down quadrant 4. But you don't have to. You can just list the two. But I think it's quite nice if you set them out nicely. Now for quadrant 1, we're going to say x is equal to... Guys, what types of angles do we have in the first quadrant? They are always acute. So that's going to be the reference angle. Right? The reference angle is always your quadrant 1 angle. So we're going to take the reference angle, which was 84,26 degrees. And now, what is the period of a Cos graph? 360. It repeats its shape every 360 degrees. So we're going to say plus 360n. Now guys, if it's the first time that you're using n, right, the first general solution that you're writing down, you have to tell me what n is. Okay, you have to add n element of z, but you only have to write that once. It's like those special triangles, right? The first time you use them, you draw them, and then you don't have to draw them again. Okay, so n element of z, you only write that once the first time you use it. Okay, then after that, you don't have to say it again. Okay, so that's our quadrant 1 general solution, guys. Always the reference angle. I'm going to make a note here. In quadrant 1, you always use the reference angle because the reference angle, guys, is always an acute angle. Do you remember from when we did angle of inclination? The reference angle is always acute. Okay, so for quadrant 1, it's just the reference angle. That's an easy one. Quadrant 4 is a bit of a different story. How do we find an angle in the fourth quadrant, guys? We did it now with our reduction formula questions. 360 minus. So we're going to do 360 minus the reference angle. And that's going to give us our quadrant 4 angle. So we're going to write down 360 minus 84,26. And again, plus 360n. The 360n you have to write each time, guys. It's just the n element of z that you only have to write once. Now we need to simplify that. We need to actually work out what this is. This is 275,74. I got a 5. 275,74. Plus 360. So guys, for a quadrant 4 general solution, you always have to take 360 minus the reference angle. Okay, always. You're always going to do 360 minus. If we have to do a quadrant 2 general solution, what do you think we're going to do for quadrant 2? 180 minus. Quadrant 3 is going to be 180 plus. Okay. So guys, once you have your reference angle and you determine which quadrants you're working with, then for those quadrants, you just use the reduction formula that we've done so far. Okay, but we are going to do some more examples. And guys, that's then your final answer. Okay, so you have 2 general solutions. So if we were to go back to that graph, sorry, now we can't actually see what the degree values are, but that first point would be at 84,26, and the second point would be at 275,74. Okay, those would be those 2 points on the graph. All right, let's do another one. Are there any questions on this one, guys? All right, number 3. Let's do one that's negative. So if we have negative sine x is equal to 0.7. We need to isolate the ratio, right? That's the first step. So I just want sine x. I don't want negative sine x. So what must I do with that minus? Divide on the other side, right? So we're going to have sine x is equal to 0.7 divided by negative 1 is negative 0.7. So that's step 1 done. Now guys, can you remember what we did with angle of inclination? If the gradient was negative to get the reference angle. Can anyone remember? Did we actually type in that negative value to get the reference angle? No, we took the positive value. Hey, now guys, what I want you to notice here is that it's negative. Sine, negative. Where is sine negative? In which quadrants? In quadrants 3, oops, that's not 3, 3 and 4. So that is how we take the minus into consideration. We're going to work in the quadrants where sine, because it is sine, right? Sine x is negative. So we're going to have a quadrant 3 solution and a quadrant 4 solution. In order to find those solutions, we need to find the reference angle. So for reference angle, we're going to do shift sine. So you can just write sine to the negative 1. But now it's very important, guys. I'm just going to show you, don't write this down. But if we do shift sine of negative 0.7, look what happens. We get a negative angle. Okay, a reference angle is supposed to be a positive acute angle. All right, so we're not going to type that negative. Like I said, the minus, we are going to take that into consideration by working in the negative quadrant. So it's not like we're forgetting the minus. Okay, just to get our reference angle, we always have to take the positive value. So if it's a negative 0.7, we're going to type in positive 0.7. Okay, and that is going to give us the actual reference angle, 44,42. Okay, so the reference angle is 44,42 degrees. I'm going to make a note next to it that the reference angle must be positive. Yeah.
And to not round up the reference angle.
Oh, it was 427. Yeah. So let's actually do this because we're not meant to be rounding at all. Hey, we're meant to only round. Let's do that. Okay, let's do it. You can even add a dot after the degree symbol. That's fine. No, you don't have to. So we're going to work with the value on the calculator. Okay. Even though we write down the value. Now, guys, the important thing here, the reason why the reference angle has to be positive. Say we work it out as negative 44, right? Then we say for quadrant 3, we're going to say 180 plus negative 44. Isn't that going to give us a quadrant 2 solution? And it can't be. Hey, it has to be in the 3rd quadrant. That's why it's very important that for your reference angle, it has to be positive. Okay, so here, you are just going to do the positive value of what you have in your equation. The minus tells you which quadrants to work in. Okay, we have our reference angle, we know which quadrants to work in, so now we can write our two general solutions. Quadrant 3 is going to be the first one, so I'm going to write Q3. I'm going to say x is equal to, how do we find an angle in the third quadrant? We do 180 plus. So we're going to say 180 plus the reference angle, which is 44,42 dot dot dot, or 43 if you want, doesn't really matter. Remember, plus 360n. You have to type this into the calculator, but anyway, so we get to 224,4, and now for this one we do have to round. Okay, because this is like a final answer thing. It was 427, so we have to round this one up, and then plus 360n. Guys, again, please remember, if you leave out that plus 360n once, you lose a mark. Okay, you have to write it every single time. So that's our third quadrant general solution. Our fourth quadrant general solution is going to be, again, just like in the previous one, 360 minus the reference angle. Plus 360n. Guys, it's always plus 360n. You don't have to think, oh, is it going to be a minus? It's always going to be plus 360n. No, so I didn't write it now because we have written it before. Okay, but if you are unsure whether you should write it or not, rather just write. Okay. All right, if I simplify this, I'm getting 315,57 plus 360n. Okay, now sometimes the angle that they give you is not just an x. They can change that angle. They can make that angle more complicated. Let me just see here. I want to see what's in the first exercise. Maybe I should just leave it at this. Yeah, I'm going. Okay, let's just quickly do this. So this was the general solution, right? We're fine so far. Now, if in number 4, they're now saying, so it obviously says solve for x. It said that in the instruction, but now they are specifying and they're saying where x is an element of 0 to 360 degrees. So now they're telling us that x is actually meant to be an angle, all angles, it can be multiple answers, between 0 and 360. Guys, if they specify, right, if they don't just say solve for x, they're now saying x must be between 0 and 360. We call this a specific solution question. All right, we've done general solution. Now these are specific solution questions. You're going to do exactly the same thing as what we did before, right? I know I haven't written the equation down yet. I'll get there now. You're going to isolate the ratio, find your reference angle, identify the quadrants, do your two general solutions. But then you're going to actually use your general solutions to find specific x values, like I did on the calculator, right, at the beginning, right? I added 360, then I added 360 times 2, and so on. So we're going to follow the exact same steps, guys. We're just going to have an extra step at the end. Okay, so I'm going to do a very simple one so that it doesn't take too long. Let's do cos x equal to 0.68. So the trig ratio is already isolated. We don't have to move anything across. It's already cos x equal to a number. Now guys, is this a positive or a negative number? Positive. So I need to look at, again, quadrants where cos is positive, so 1 and 4. So we're going to have a quadrant 1 solution and a quadrant 4 solution. Guys, that means that at the end, when I'm writing x is equal to this and x is equal to this, one of those values is going to be a value between 0 and 90, right? Because that is what we get in the first quadrant. And the second answer is going to be between 270 and 360. Okay, so the actual x values that I'm going to get, the specific answers, are going to be values in the first and the fourth quadrant. You'll see now when we do it. Okay, so let's find our reference angle. RA is going to be shift cos of 0,68. I'm going to write it on the side here because I'm running out of space. So it's 47,156. So you can round it off to 47,16 if you want. Okay, that's the reference angle. We're going to find our quadrant 1 general solution. In the first quadrant, we just use the reference angle, right? So it's just going to be 47,16 degrees plus 360 in. And guys, we haven't done tan yet. We're going to do tan tomorrow because it is slightly different. So that's the first quadrant solution. Quadrant 4, how do I get an angle in the fourth quadrant again? 360 minus the reference angle. So 360 minus 47,156, or just 47,16 if you want, plus 360 in. So that gives me 312,84 degrees plus 360 in. Same method, guys. Even though they've asked for specific solutions, we have to get the general solutions first and then use those two solutions to find our specific solutions. So now I want you to write there for x is equal to, and now we're going to list the specific solutions that we're going to get. Guys, we're looking for x values just between 0 and 360. Okay. So now what you're going to do is you're going to look at your, what's this called, your general solution. Remember, n can be an integer. Okay. So I always start at 0. Because what do I get if I say 360 times 0? What's anything times 0? Just 0, hey? So then I'm going to have 47 plus 0, which is what? 47,16. Does that fall between 0 and 360? Yes. So that is going to be a solution. Do you guys see that is the first quadrant solution that I spoke about at first? Right? You have to get an angle that's either in the first quadrant or in the fourth quadrant. Because that's the only way that cos will be positive. Okay. Now you're going to use a semicolon because that's not going to be the only answer here. Guys, what number comes after 0? 1, okay? Remember I said I'm making n 0, and that gives me this answer. If n is 1, what is this? 360 times 1 is 360. If I add 360 degrees to 47, am I still going to get an angle between 0 and 360? No, so that's not going to work. Okay. So now if I make n2, is that going to give me an angle between 0 and 360? If I have this plus 720, no. All right, so you can stop. What if I go backwards? What if n is negative 1? Because remember, an integer can be a negative number as well. What's 360 times negative 1? Negative 360. 47 minus 360, does that give me an angle in this between 0 and 360? 47 minus 360, that's going to be negative, hey? So it can't be. Do you agree? Okay, so that doesn't work either. So guys, this general solution only actually gave me one specific solution that falls within the interval that they gave. They can change the slope. They can make it like negative 360 to 360. Okay, then you need to keep trying, but we'll do more tomorrow, don't worry. What about this one? Let's check this one. If n is 0, what am I going to get here? 312 plus 0 is 312. Does that work? Does that fall between 0 and 360? Okay, 312, doesn't it?
Yeah.
Yes. Okay, so 312,84 degrees, that also works. And that's a fourth quadrant one. Hey, remember I said we're going to get a quadrant 1 answer and a quadrant 4 answer. Guys, if I add 360 to 312, that's going to be too big. Right? Do you agree with that? It's going to be 672, whatever. So that's not going to work. What if I make n negative 1? 312 minus 360, is that going to be a negative answer?
Yeah.
312 minus 360, hey? And my answer can't be negative. It has to be between 0 and 360. So guys, those are the only two solutions of these general solutions that fall within the interval that they gave us. Okay, so these are your final answers. But you have to go through the same route. You first get your general solution, and then you write your specific solution at the bottom. Okay, we'll do more tomorrow where we actually write it out properly. But that's what you need to do if they've given you a specific interval. Okay, so exercise 15. And guys, if they're asking for a specific solution and you don't know how to do this last step, you can still do all of this, right? Yes, okay. Exercise 15. Page 155. And now I can't give you guys 10, so let's do number 6 and 7. And now why is there smaller than or equal to? Surely not. Okay, number 12 as well, but guys, can you just check in your textbooks and mine that has an inequality symbol for number 12? It looks like that. That should just be an equals. So if it says that in your textbook, we never ever do trig inequality, so you'll never get a question like this in matric either. So if, hey, is it? In all of your, oh, so maybe I have an old version of this book. Okay, so then that should be fine. 6, 7, and 12. I'll write them down for you quickly because I know some of you aren't fans of bringing your books to class. So cos x is negative 0,813. Is it? Okay, yeah, so if you can just change it then. 7 was 3 sine x plus 1 equals negative 1, and 12 well, guys, don't be put off when you see the square root of 3. You're just going to move it and divide by 2 and use the calculator anyway, right? So please don't think, oh, there's a cert, I don't know what to do. You're just going to find, it's going to follow the exact same steps, and you just use your calculator to find the reference angle. You don't even have to worry about that sort of thing. Now guys, for all of these, they're saying you must solve for x where this is happening. What does that mean? We're going again from 0 to 360. So it's like the one that we just did, guys. This is the same, it's a different way of saying x is an element of 0 to 360. It means the exact same thing, right? It's saying that x has to be an angle between 0 degrees and 360 degrees. So you're going to do that last extra step that we did in the last example. But like I said, if you didn't understand that, you can leave out that last step, but you can still do all the other 4 steps before that. Okay, so don't come tomorrow and say you didn't understand that general solution.